All right, welcome to the video on solving simple equations. Simple is in quotes because simple is not always, it's like a relative term, right? What's simple to you may not be simple to the person next to you. And what we're doing is basically solving one-step equations. You can put the date over here, right here. You can put the date. And this is really 1.1, Chapter 1, Section 1 of Algebra 1. And the question that I want to lead off with is, who is the fastest runner of all time? And who knows who the fastest runner of all time is? The fastest runner of all time, yes. Usain Bolt. So, Usain Bolt is the fastest runner of all time. Do we know what he runs the 100 meter in? The 100 meter. So that's one of his races. Anybody know his time? All right, so I just snipped this article, and it shows that Usain Bolt has won the world championship 11 times. His record is the 100 meter at 9.58 seconds. 9.58 seconds. So this is basically important to understand. Let me put this so it doesn't look like a 5. And we want to get an idea of how fast he runs. And we're going to come back to this question later. And we're going to solve an equation to figure out how fast he ran the 100 meters so we can get a better idea of how quickly he would get across this room, for example. Because it's kind of hard to understand how fast that is. But if we have an idea of how fast he can go in each second, right, then we'll understand it better. So we're going to circle back to this. I'm jumping around a little bit. I have this right here, a picture of our friend Thanos. You may know him from the Marvel Cinematic Universe, yes? I have used this meme for a reason. He says, perfectly balanced as all things should be. Who can tell me why I selected this, aside from the fact that I like the movies? Yes? To say if you do one thing to one side of the equation, you have to do something to the other to keep it balanced. That's right. So because this class is all about understanding this, the legal scale, right? The pan balance, they call this. So we want to always think about this when we are in this course. So if we do something to one side of the equation, we must do it to the other. And our idea is to kind of undo operations in this class. So think about it this way. If you tie your shoe and then you untie your shoe, have you made any progress in the morning? No. So if you tie your shoe and then you untie your shoe, you haven't made any progress. So that's something we need to think about, right? So we know that if you are waking up in the morning, you tie your shoe, and then you untie it, you've made no progress. So tying and untying are inverses of each other. They undo each other. You won't make any progress. And that's what we kind of want to do here. We want to like neutralize or like cancel things out or like undo things. So in algebra, we have to keep things perfectly balanced or we can't put an equal sign. Every time we put an equal sign, we're saying that this right here is happening. And if we want to put an equal sign, we have to keep it balanced. Otherwise, it goes out of balance and we can't put an equal sign. It's illegal. So the general idea is pretty simple. I want you to underline or highlight this. Adding the same number to each side of an equation produces an equivalent equation. If you add the same thing to both sides of an equation, you're going to get an equivalent equation. In other words, if you add 5 to both sides of an equation, or any number, positive or negative even, you'll get an equivalent equation. You can use an equal sign. The equal sign holds. And furthermore, because subtraction is basically adding a negative number, think about that, subtraction is really adding a negative number, then subtraction works the same. You can subtract something, the same number, from both sides of an equation, and that's going to give you an equivalent equation. So really all you want to do is underline those two statements because they're pretty important. So let's go ahead and see what this looks like in practice. Some of you may be, maybe thinking this is a little slow for you. That's okay. And maybe some of you, this is really good to like get through this whole deal. So we're going to go through it step by step, and we'll pick up speed as we get more skills and more competent. So let's go ahead to the bottom of the page, or the middle there, and start solving some equations. So I wrote some things out. This says which operation, and I'm asking you which operation is happening to the variable. So I guess you have a choice of telling me it's addition, subtraction, division, or multiplication. So which operation is happening to the variable? Which operation? Yes. Subtraction. Good. So you write subtraction under the answer. I wrote, that's how I set it up. It's a weird way to set it up, but I wrote subtraction is happening, so I'll use what? Yes. Addition. Perfect. So there was subtraction, so I'll use addition. So what I'm just going to show you is that we have addition happening, so I'm going to add 3 to both sides of the equation. Why did I add 3 to both sides? Because perfectly balanced, as all things should be, right? And if I do that, I can keep this equal sign. I can bring this equal sign, and I'm going to bring it all the way down here, down. Now the question is, we know that this, negative 5 plus 3, is negative 2. More on that if you have trouble with those types of numbers, but hopefully you're okay. And now here, I'm going to take another color, blue, and I'm going to circle this, and I'm going to ask you what happens to negative 3 and positive 3. Yes? It cancels out. Now, when I say it cancels out, what mathematically is happening? Why does it cancel out? Like, what's going on?
So, because it's subtraction 3 and then you add 3.
Yep.
It becomes 0.
Perfect. Subtracting 3 and adding 3 will make this become 0. So it's really like you're adding 0, x plus 0. You don't need to write that because you don't need to put a plus 0 because nothing's happening. X and then do nothing to it, like add nothing, which is really just x. So x is equal to negative 2 is your answer, okay? And hopefully you're feeling pretty comfortable with that. I'll go a little quicker through the next one. We look at this and we see that the operation happening to the variable, and just to kind of clarify this, I'll do that for you. The operation happening to the variable here is addition. And we want to get rid of addition by using subtraction. So fill that in and then think about what you're going to subtract. You're going to subtract 2.8, right? So you subtract 2.8 on the right. If you subtract 2.8 on the right, what must you do? Subtract 2.8 on the other side on the left. Yes. And so now we can say, sorry about the space issue here, we have the equal sign. These cancel out. We talked about why, so now I'm going to say cancel out, but that's because they add to 0. And adding to 0 is not really worth writing down. Some of you are going to not want to have your y on that side, so I'm going to put it over here. I'm just swapping the sides. This is going to come out to a negative. It's like you had 9 cents and then you spent $2.80, so you are in the negative. You had to borrow some of that. You actually had to borrow how much to get there, I guess? How much did you have to borrow? $1.90, 1.9, I think. So what you're doing is you're subtracting and keeping the sign of the higher number. When you have numbers that have different signs, addition and subtraction that is. So addition and subtraction has its own page on this note handout. And multiplication and division have this own page. Addition and subtraction are closely related. They're inverses. They always kind of work the same way. And multiplication and division are different than addition and subtraction. There's totally separate rules for them. And they work the same way as each other, but not the same as addition and subtraction. So be careful of that. So this is our answer, y equals 1.9. So now what I want you to do is scroll down and pause the video and give these problems a shot. They say now you try because what's supposed to happen is now you're supposed to try them. So pause the video and give these problems a shot. Okay, so now that you've tried these problems, I can tell you the answers. I won't write them, but the answers are negative 10 to number 1. The answer to number 2 is negative 1/3. And if I'm not mistaken, the answer to number 3 is negative 10.4, right? Negative 10.4. Be careful because that does come out to negative 10.4 because you're subtracting the 3.9 on both sides. And then you're going to add up both of these negative numbers to get a bigger negative number. And we are on to the next page. So the things you want to highlight are really just the sentences Very simple, but different rules. It's on a new page for a reason, so everything's changed now a little bit. Multiplying each side of an equation by the same non-zero number, they have to throw that in, because if you multiply by 0, it's just weird, produces an equivalent equation. So multiply both sides by 5, you got an equivalent equation. You can use an equal sign. If you divide each side of the equation by the same number, that's also going to be an equivalent equation. The equal sign will hold. So that's the general idea here. If you multiply both sides by the same number or divide both sides by the same number, then you get an equation again. So let's go through a couple here, bless you. We're looking at these ones. And I might make a tweak to this just for the fun of it. I think I will do that here. So I'm going to change this problem in a second. I'm getting a little ahead of myself, but I don't want to forget. I'm going to make this negative 12 pi equals 4 pi x. That's what I want to do. So this is a change because this is a little bit harder, and I know that these problems are going to show up. Okay. A, what operation is happening? Answer that, please. Yes. Division is happening. So division is happening to the n. And I'm going to put this negative on the bottom. Let me just show you a quick thing. Real quick over here. If you have negative 1/2, that's the same as negative 1/2, and that's the same as 1 over negative 2. Okay? This is important. Pause and look at that and think about it if you don't quite get it. But basically, negative 1/2 means either the top is negative or the bottom, not both. Not both are negative. So I can put that negative that I have in this equation to either the top or the bottom, and I'm going to put that negative in the bottom here. So I'm going to make this a negative 5, you know what I'm saying? So I'm just going to put that in the bottom. And I'm going to say it is division. Sorry, this is a scribble mark. Division. So I'll use, what do you think? Say it. I'll use multiplication. Multiplication, I didn't have space, so I put multi, dot. I'm going to multiply by what? Am I going to multiply by negative 5 or am I going to multiply by 5? That's a good question, yes? Good, I'm going to multiply by negative 5 because we're not changing subtraction to addition. It's when we're changing subtraction to addition that we would change the sign. But we want to keep the sign the same. It's that we're changing division to multiplication. So we multiply by negative 5 on both sides. Now, what happens here with the negative 5 multiply and the divide negative 5? If you took a number and you multiplied it by negative 5 and then you divided it by negative 5, what would happen? Let's think about that for a second. So take a number, let's take the number 74 and multiply it by negative 5. So I'm going to multiply by negative 5. And I got, oh, sorry, it didn't really work because I don't know why, but 74 times 5, that's negative. I think I have to do it that way. There we go. So we got negative 370. And now I'm going to divide that also by negative 5. So I multiplied by negative 5 and I divided by negative 5. And what did I get back to? The same number, right? So if you take any number and you multiply it by, let's say 7, and then divide it by 7, it's like tying and untying your shoe. So this is just going to go back. So why do I cancel these out? Why can I cancel them out? Because what? Why can I cancel them out? It actually doesn't equal 0, interestingly enough, because that was on the previous page. It actually equals 1. Negative 5 divided by negative 5 is 1. So I have 1n equals whatever this is. And that's 15. A negative times a negative is a positive. I put 1n equals 15, but I don't really need to put 1n, so I'm just going to change that 1 into part of my little box. And that's my answer. Okay? We'll do the next one, and then we may skip part C, even though there's some old skills there, because I don't want this video to be super long. So the next one says what operation is happening. So what operation is happening to the variable? Is pi a variable? Is x a variable? Are they both variables? Thoughts on that? What is pi? Pi is a number, isn't it? What is pi equal to? Do you know? 3.14, yeah? 3.1415926, something like that. So since pi is a number, it's not a variable. It doesn't change. It's always 3.14. It's not like pi is going to be something other than 3.14 tomorrow. It's a number. but it's like a number that's like hidden inside there, right? You don't see actual numerals like actual digits. So the variable, what's happening to the variable is when these things are squished in together, that's multiplication automatically. You see a variable squished up against something, it's multiplication. When things are squished together, it's multiplication. So what's operations happening here? It's multiplication. Multiplication. So that's what's happening. So how will I get rid of multiplication? I'll use division, right? So I'm going to divide on both sides by 4. Well, actually, I'm not just multiplying by 4, right? What am I multiplying by? Yes? 4 pi. So I'm going to divide by 4 pi, which is really like 12. 3.14 and 4 times 4, right? 3.14 times 4. So I'm dividing by 12-ish. 12-ish. So if I divided by 12-ish over here, I should divide by 12-ish over here. What should I divide by over here? 4 pi again. Don't think about it that way. You got to divide by this no matter what. That tells you 4 pi. What do you think I can do with the pi's now? We can use the term cancel if you like. Yes? What can? Exactly. So the 4 pi and the 4 pi can cancel. How about over here? Perfect. Yeah, but actually, the pi's will cancel. So you can cancel the pi's, but you can't cancel the numbers. You must divide them. So I'm going to bring this down, and I'm going to have -3 equals x. And that's my answer. So that's kind of where we're at. So hopefully that makes sense. Does that make sense to everybody there? Good? Okay, cool. So what I want you to do now is we're going to wrap it up here. We're going to pause the video and give these problems a shot. They're not too bad. So pause the video and give these a shot. And once you finish that, I will see you in the next video. Peace.